Hey there, this video will help you with 1.04 inverse functions. Inverse functions really aren't too difficult, but if you haven't done them in a while, it can be a bit confusing and sometimes overwhelming. So let's go over the type of problems you'll need to make sure you understand to do well on the assessment. So the first most basic thing is to find the inverse. So finding the inverse are some very simple steps that you just want to make sure you memorize so that you can follow. So first thing I'm going to do is I'm going to grab a pen here and let's do a nice color. Well, let's do a nice blue. And so what I want to do first is just forget that f of x is even there. Make it a y. So it becomes kind of what you did in algebra 2. And now what you want to do, the very first thing you want to do is you want to swap x and y. So I'm just going to swap them. So I'll make that x and that y. Literally swap them. Don't go moving stuff that's near the y or near the x. Just literally swap them. And then the next thing I want to do is now solve for y. So in this case, in order to get y by itself, I first need to square both sides to get rid of that radical sign. So it becomes x squared is equal to y plus 9. Now to get the y by itself, I'm just going to minus 9 on both sides. And I'm going to get x squared minus 9 is equal to y. Now the very last thing you're going to do is just change the notation. So all that means is I'm going to put, instead of y, I'm going to put f of negative 1 of x, means the inverse function is the x squared minus 9. And it's as simple as that. Just be careful with the radical signs because you've got to work it out the order in which you see them. So here, to find the inverse, I'm going to do the same steps. I'm going to rewrite it with a y. Y is equal to 3x to the fourth plus 2. Then I'm going to swap that x and that y out completely. Now I'm going to begin solving for x. So I'm solving for y, minus 2 on both sides. And you get x minus 2 is equal to 3y to the fourth. I'm going to then divide by 3. And start working on getting the y by itself. And I've got x minus 2 all over 3 is equal to y to the fourth. Now to get rid of that fourth power, I'm going to fourth root. But I got to do it to both sides. And I'm left with y equals the fourth root of x minus 2 over 3. Then the very last thing again is just to change your notation. That's the way you're going to see it. F negative 1 of x is still equal to that fourth root of x minus 2 all over 3. And you just found the inverse of that function. So this last one's going to be a little easier because it's not quite as complex, but same steps. Again, I'm going to make y instead of f of x, so y equals 4x plus 2. Swap that x and y. And now I'm going to start solving for y. Begin my minusing 2 on both sides. And then divide by 4 on both sides. And that gives me y is equal to x minus 2 all over 4. That's my inverse. But the last thing is we want to make sure we put it in the correct notation. So the inverse function, f negative 1 of x, is equal to x minus 2 over 4. And again, no matter how complex the problem looks, the process for finding the inverse remains the exact same. So now if you're given a graph, we want to find out if they're one-to-one function. So is their inverse going to be a function? So in the previous lessons, we did the vertical line test. For one-to-one, you're going to do what's called the horizontal line test. So I'm just going to create a horizontal line through each one of these. Notice this first one, it crosses 1, 2, 3 times. The 3 times it crossed. On this one, we got 2 times. And on this one, we've got just the one time, okay? The rules for the horizontal are the same as the vertical. If it passes more than once, then no, it's not a one-to-one function. So in the vertical, it was just, is it a function? Horizontal is it a one-to-one function? So if it passes 3 times, that's more than once, so no dice. This guy, twice, more than once, not a one-to-one. This guy, once, oops, the excitement of saying no. Yes, that is a one-to-one function because it only passed one time. Then you're going to need to also be able to prove that functions are inverse. I can't just say they're inverses of one another. I need to figure out if they are or not. And it's not as complicated as it sounds. So what I'm going to do is I'm going to take f of x. And what I'm going to do is I'm going to input g into it. And the goal is you want the answer to come out to be x. If that's true, then they're inverses of each other. So what I'll do is I have 9 over x, but instead of x, I'm again going to replace it with the g of x, which also happens to be 9 over x. So this is what's called a complex fraction, like a fraction within a fraction. So the easiest way to deal with these is to write them horizontally. The numerator is really just 9 over 1. It is being divided by the denominator, which is 9 over x. And remembering our rule of fractions, we're going to keep the first fraction the same, change it to a multiplication, and flip the fraction of the second one to its what we call reciprocal. So then we're just going to multiply straight across our numerators and our denominators, so it becomes 9 times x is 9x over 9. The 9's cancel out, and I'm left with x. You also could have known that here, where the 9's are going to automatically cancel out, depending on the way you were taught, but I wanted to show it both ways. So yes, it is x, so it means they're inverses. But you should also check g of f of x as well. But because these two are the exact same, I know my answer is going to come out to be the exact same either way. So that means, yes, they're inverses of each other. So in order to get full credit on the essay portion of this particular assignment, you will need to show both. Or when you show your first one, explain that the second one is also the same as the first, giving you the same answer. And because both give you an answer of x, then they are indeed inverses of one another. And that should be all you need to help you with this particular assignment. Good luck.